Okay, let's just dive right into this. Welcome to today's Explainer, where we're unpacking a massive, fundamental shift that's happening right now in the world of work. Enterprise AI is packing its bags, moving out of those isolated little chat windows you're used to, and stepping directly into your team's workflow. It's an incredibly exciting moment, for sure. But that exact placement creates a hidden structural danger that we urgently need to solve if we actually want to get real work done.
Seriously, ask yourself what actually happens when AI stops being just a passive tool waiting for you to type a prompt and instead becomes a full-blown coworker. Imagine dropping a highly active, incredibly powerful intelligence right into the middle of your company's busy Slack channels. On the surface, sounds amazing. But without a structural chassis to guide it, letting an AI loose in your organizational communication streams fundamentally changes the dynamic of your entire workspace. And honestly, it's actually quite risky.
Section 1. The Shift to Coworkers. The Embedded AI Evolution. Consider this number, 65%. Wrap your head around that for a second. This isn't just some neat little toy demo meant to impress investors. According to our sources, Anthropic's own product team reportedly uses an internal version of Claude Tag to produce about 65% of its code. Think about what that actually means. The AI is doing real heavy lifting production work. It's down in the trenches with the engineers, turning casual discussions into actual enterprise output.
So, this new AI coworker fundamentally changes the workspace, and it does it through three concrete capabilities. First up, shared context. It's no longer just you in a private chat. The AI is sharing the team's operational context right there in the channel. Second, persistent presence. It doesn't just answer one single question and vanish into the ether. It persists continuously over time, actually learning your project's habits. And third, proactive intervention. In ambient mode, it can literally observe your team's discussions and proactively flag unresolved issues or pending decisions without even being asked. It's stepping right into the driver's seat. Moving to Section 2, the embedded AI problem. Placement versus discipline.
Here is the absolute core thesis of this whole thing. Just placing an AI inside Slack doesn't automatically make it reliable, controlled, or auditable. A model living inside your channels can still easily drift off topic. It can misunderstand tasks entirely, or worse, it could confuse a casual team brainstorming session with a finalized, binding decision. The placement is there, sure, but the discipline? It's completely missing. If we break down the structural risks, we start to see that an ungoverned AI can become highly active but structurally really unsafe. It might misunderstand what the actual object of work is amidst a chaotic thread. It might cross evidence boundaries. It can burn through enormous, uncontrolled token costs just because it's constantly reading every long, winding chat history. And perhaps most concerning of all, it can easily drift into becoming this invisible managerial surveillance mechanism, silently tattling on who left a ticket open or who went to lunch rather than, just assisting the team.
The crucial contrast here really boils down to placement versus control. Tools like Claude Tag brilliantly solve the placement problem. They give the AI access, they create a ton of convenience, and they generate activity by putting the AI right where the work happens. But they completely lack the control layer required for serious enterprise reliability. You don't just want a bunch of activity, you want valid execution, auditability, and deductive discipline.
Which brings us to Section 3, enter the energetic paradigm, the missing control.
Okay, let's look at how the energetic paradigm, or EP, actually pulls this off, starting with task-object definition. Slack threads are notoriously messy, right? They're filled with complaints, side jokes, partial diagnoses, and maybe, eventually, a proposed fix. Before the AI even acts, EP defines the true object of work. It separates all that messy human context from the core problem, ensuring your AI coworker doesn't just blindly react to the last angry message in a thread, but actually identifies the exact required output. And defining the task naturally builds right into routing and boundaries. Because let's face it, not every ping in a chat channel carries the exact same weight. EP routes tasks based on their proof burden and risk level. It sets explicit semantic, data, and procedural limits way before execution even begins. This prevents the AI from treating a casual, low-stakes question about a product metric the exact same way it treats a highly sensitive, high-risk legal or customer data query. But speed can often hide weak reasoning. A bot can spit out a blazingly fast answer that looks great on the surface, but is fundamentally flawed underneath. EP forces the AI down an inspectable, deductive path. It has to move logically from constraints to valid operations to a checkable output. This ensures your organization sees a verifiable, step-by-step route rather than just trusting some mysterious instantaneous result. Actually, I find this next part absolutely fascinating: failure to rule memory. The strongest enterprise systems out there don't just patch individual errors. Instead of just correcting one mistake in a vacuum, EP converts organizational failures, like, say, a historically misunderstood bug report, into permanent, reusable rules for the AI. If the AI messes up, EP captures that failure pattern and turns it into a future checkpoint. It learns operational rules, meaning your AI literally gets smarter about your specific business over time.
Then there's the hidden economic drain: energy and cost control. A persistent agent reading every single message in a busy channel is going to burn through tokens at an astonishing rate. EP acts as a vital economic brake. It stops the AI from unnecessarily reading endless histories by narrowing its valid action path. Through strict path discipline, it only consumes the context and energy required for the specific task at hand. It's a massive cost saver.
Finally, we absolutely have to talk about governing the uncontrolled manager. Remember that surveillance risk we mentioned a minute ago? EP makes management logic totally explicit. It sets hard rules on what the AI is actually allowed to flag, what counts as unresolved work, and who exactly it reminds. This governance ensures that your proactive, helpful assistant doesn't silently mutate into an uncontrolled, invisible manager breathing down your team's digital necks.
Section 4. Building reliable enterprise AI. Let's look at the big picture. Breaking all of this down, the energetic paradigm maps a structural answer directly to every new enterprise risk created by placing AI in your channels. Need to handle shared context safely? EP defines the task object. Need proactive reminders? EP governs what gets flagged so you avoid surveillance. Worried about that token cost pressure? EP reduces context via strict path discipline. It is a direct, point-by-point solution to the chaos. Ultimately, interface tools like Claude Tag are asking, where should the AI live? That's just placement. But the energetic paradigm is asking the harder, much more valuable question: how must the AI work so it can survive serious, everyday use? Placement creates access, sure, but EP creates valid execution. The reality is, your AI has officially moved into the workspace. It's literally sitting next to you in your channels right now. So the next time you see an AI dropped into a workflow, ask yourself, do we just have convenient placement? Or do we actually have the energetic paradigm control layer required to truly trust it with our real work? Thanks so much for diving into this explainer with me, and definitely keep questioning how your tools are actually operating beneath the surface.